I was at like a coffee shop this morning and I was just watching the barista work. It was kind of fascinating.
Right.
It's just tap a screen, a label prints, swipe a card, a payment clears, and then, a notification pops up on someone's phone saying latte is ready.
Yeah.
It feels like magic. We have this sort of collective hallucination that behind the screen there's this pristine, well-oiled machine.
Master plan.
Exactly, a master plan where every gear turns exactly when it's supposed to.
It is a very comforting illusion, isn't it? We like to imagine a conductor leading an orchestra.
Right.
But if you actually pull back the curtain on most enterprise systems today, a bank, a hospital, you name it, you don't find a conductor. You find what our sources for today call the accidental architecture.
Accidental architecture, that sounds expensive.
It is.
And honestly, a little terrifying. It implies nobody actually meant to build it that way.
That is exactly what it implies. And it's the perfect starting point for our deep dive today. We're looking at a stack of articles focused on a concept called the enterprise control plane, drawing from insights on the Odyssey platform.
Okay.
And we're going to unpack why businesses have spent, the last 20 or 30 years speeding up execution
Just getting things done.
while,
Mm.
controlling how they get things done.
And that's our mission for this deep dives, right? To
Mhm.
understand why, as we start dumping AI into these systems, that is about to become a massive problem.
Well, a huge problem.
The analogy that jumped out at me from the reading was the sports car. It's like we've been building a faster and faster engine, but we forgot to install a steering wheel.
That is a very apt analogy because the central tension here is that we are moving from a world of rigid, clear-cut rules to a world of probabilistic AI.
Mm-hmm.
And our old systems just aren't built for it.
So we're going to talk about this messy code, this layer cake, and something called the exception economy.
And then finally, this solution of a control plane.
Okay, let's start with that accidental architecture, because I think most people, myself included, assume that if a Fortune 500 bank has software, someone, designed it on purpose. You're saying that's not really the case.
Well, someone designed the pieces on purpose,
Oh, okay.
but nobody designed the whole.
Yeah.
The sources describe it as the path of least resistance. Over 20 years, a business adds a rule here, a patch there, a new service over here.
Right. It's like a home renovation. You fix the kitchen, then 5 years later you add a bathroom, then you patch the roof. But you never actually looked at the foundation to see if it could hold all that extra weight.
Exactly. And the source uses a great visual for this, the geological layer cake.
Okay.
Imagine your business software as layers of sediment deposited over time.
Mm-hmm.
At the very bottom, you have the foundation layer. This is simple stuff. Send an email. Process a payment.
Clean. It
Right.
works.
It works. But businesses don't stay simple. So next comes the logic layer. This is where business rules creep in. Process this payment, but only if the amount is under $500.
Mm-hmm.
Then right on top of that, you get the exception layer. And this is where the panic starts to set in. Do all of that unless it's a VIP customer.
Yeah.
Or unless it's a weekend.
Or unless the fraud score is weird.
Precisely.
Yeah.
And I can see you know where this is going.
Exceptions to the exception.
And then the integration layer. You have to coordinate between 3 different services.
Oh, man.
Check the fraud score, wait for the bank API, then update the CRM. And now we're just pouring the AI layer on top of all of it.
Use this LLM to predict if we should pay, but override it if the confidence is low.
Exactly.
So you just end up with this lasagna of logic.
A lasagna where nobody remembers the recipe. And the consequence, as the articles point out, is that updating your system becomes an archaeological expedition.
An expedition, right.
If you want to change one business rule, say the definition of a VIP customer, you have to dig through 5 layers of code across 12 different services to find every place that rule is hidden.
That brings up a quote from the source that really stuck with me. Nobody understands the whole system anymore. That's a chilling thought for a CEO.
It is.
You're running a company, but the actual logic of how it runs is buried in code written by a guy named Steve who left 3 years ago.
And Steve didn't leave any documentation.
Of course not. Why would he? But here's where I want to push a bit. We've had spaghetti code for decades. We've managed. Why is this suddenly an existential crisis? The sources seem to suggest AI changes the game.
It does, fundamentally. And this is the technical core of the argument. We are shifting from deterministic software to probabilistic AI, and that breaks the accidental architecture completely.
Okay, let's unpack that. Deterministic versus probabilistic. Because it sounds academic, but the implications are huge.
Think of it like a light switch versus a dimmer.
Mm-hmm.
Traditional software is deterministic.
It's on or it's off.
Right. It's binary. Yes or no. If the account balance is greater than the withdrawal amount, dispense cash. It's rigid, but it's traceable. You can look at the code and know exactly why it happened.
If the math works, the money moves. Simple.
But AI doesn't work like that. AI is probabilistic. It doesn't say yes or no. AI says, given this customer's history, I am 73% confident this is not fraud.
That's 73%.
Right. And what do you do with 73%?
I have no idea.
If you embed that probabilistic number into a rigid, hard-coded business rule that's buried in your integration layer, complexity just explodes.
So you're not just debugging code errors anymore. You can't just look for a missing semicolon.
No. The source makes this point really clearly. You aren't just debugging what happened. You're trying to figure out why the model had that confidence level, which hard-coded business rule overrode it, and in what order that happened across 3 different microservices.
It's a needle in a haystack, but the haystack is distributed across the cloud, and half of it is a black box.
Precisely. This creates a traceability crisis. Decisions become almost impossible to explain. Risk just accumulates quietly, as the text says, outside anyone's line of sight.
Until a regulator asks, why did you deny this loan? And you realize you literally can't answer.
You can't, because the decision was a mix of 3 old rules and 1 AI guess.
And that leads us directly to the money, because if this was just an engineering headache, maybe the board wouldn't care. But the source material talks about something called this exception economy.
It's a fascinating concept. The premise is that in most modern companies, the happy path—
where everything goes right.
Exactly. The data is clean, the customer is standard. That's all automated now. It's cheap.
Right, that's the sleek machine we talked about at the start.
But the exceptions, where things go off script, are incredibly expensive. The numbers they gave were that 20 to 30% of work goes off script.
Which doesn't sound too bad. A quarter of the work.
Seems manageable, right? It's the cost of doing business.
Yeah.
Until you hear the second half of the stat. That 20 to 30% of work consumes 60 to 80% of operational costs.
Wow.
And nearly all executive attention.
So the minority of the work is costing the majority of the money.
Think about insurance claims. 70% might fly through automatically. Great. But the 30% that have a fraud suspicion?
Those need human investigators, phone calls, legal reviews.
All of it. Or healthcare prior authorizations, or a bank trying to handle a KYC alert.
Oh, your customer, right?
Those are the perfect examples. And here is the paradox the sources highlight. As we introduce AI, we use it to automate the easy stuff even more. We get really good at the high volume, low complexity work.
Which clears out all the easy tasks, so the only thing left for the humans.
That is the nightmare fuel. The weirdest, hardest, most high-risk cases, the exception economy just expands.
That's a really counterintuitive point. We think AI will make our employees' lives easier, but it actually removes the easy wins and leaves them with nothing but the hardest problems.
And if you don't have a control layer to manage those exceptions, to route them, track them, audit them, they become black holes. Accountability just breaks down.
Because it's all happening in emails and Slack DMs outside the official system.
Exactly. You have high-paid humans doing manual work on cases that are basically invisible to your central operations.
So to recap the diagnosis, we've got an accidental architecture that's impossible to update. We've got probabilistic AI making the logic fuzzy. And we have an exception economy eating all our profits.
A cheerful picture, isn't it?
Thrilling. I'm practically sweating.
Okay.
So let's talk solution. The sources pitch this idea of the enterprise control plane. Now, I have to be the skeptic here for a second. My first thought was, oh, great, another piece of software.
I get it.
Is this just a new ERP? Is it a fancy CRM?
It's crucial to define what this is not before we define what it is. And it is not another execution system. It sits above them.
Okay, so give me the mental model.
Think of it as air traffic control. The planes, that's your ERP, your AI agents, your payment gateways, they're all doing the actual flying. They execute the work. The control plane is in the tower, tells them where to go, when to land, and ensures they don't crash into each other.
The mantra the source uses is execute locally, govern globally.
Right. Execute locally, govern globally.
Right.
This is about decoupling the decision from the action.
Can you give me a concrete example of that? Let's go back to the VIP customer thing.
Sure. In the old accidental architecture, the logic for if VIP, then give free shipping is hard-coded into the shipping software itself.
Right.
In a control plane architecture, the shipping software just pauses and asks the control plane, here's a customer. what shipping rate applies.
And the control plane checks all the rules?
It checks the rules, checks the customer status in the CRM, maybe even checks an AI model for churn risk, and sends back a simple decision: free shipping.
And the shipping software just does what it's told. It doesn't need to know why.
It doesn't care why.
I see. So if I want to change the rule to only VIPs who spent $1,000 last month get free shipping, I change it in one place, in the control plane.
Exactly. You change it once, and every system in your enterprise instantly follows the new rule. No archaeological expedition required. This is called selective centralization.
Selective.
Yeah, you don't want to control every tiny variable. That creates a bottleneck. You just centralize the rules that matter: the cross-boundary decisions, the compliance logic, and those high-risk AI boundaries.
And that touches on the AI part again. The sources mention a plugin model for AI. How does that stop the black box problem?
Well, instead of embedding AI deep into your workflows where you can't see it, the control plane treats AI as a governed component. It's just a plugin.
So the AI reports to the control plane, like an employee to a manager.
Correct. The control plane says, okay, AI, give me your recommendation on this loan. The AI says, I'm 70% sure it's safe. Then the control plane checks its own governance policy and says, our policy says 70% isn't enough for a loan of this size. I'm routing this to a human manager.
So the control plane acts as a supervisor. It can veto the AI.
It can veto, it can route, and most importantly, it records the entire interaction for an audit trail.
Which brings us to the boring but critical topic: compliance.
I would argue it's not boring anymore, it's survival.
A fair point. Usually when I hear compliance, I think of people with clipboards slowing everything down.
That's the traditional bolt-on approach. You build a car, then you try to bolt the brakes on later. The control plane makes security foundational. It's built in.
There was a feature mentioned in the Odyssey text called shadow mode. I thought that was really cool.
Shadow mode is brilliant for risk reduction. Imagine you have a new AI fraud model. You think it's better than your old one, but you aren't sure.
Right. In the old world, you just have to flip the switch and pray.
Or test it on old data, which never really matches reality. With the control plane, you can run the new model in shadow mode. It receives live data, it makes decisions.
But those decisions aren't executed, they're just logged.
Exactly, so you can watch it working in the real world, side by side with your current system, without breaking anything, like a flight simulator using real weather data.
That feels like a game changer for anxiety levels.
It creates what they call a continuous provable state of compliance. When an auditor comes in for ISO 27001, SE2, whatever, they ask for evidence.
Show me why you made these decisions.
In a messy architecture, you're scrambling. You're trying to call Steve. Oh, wait, Steve left.
Right.
With a control plane, you have a single source of truth. Why did you deny this loan? Here's the log. The AI scored it at 40. The business rule for this region requires 60, and the decision was made at this timestamp. Done.
It shifts compliance from a frantic scavenger hunt to just pointing at a dashboard.
And that is the real definition of governance. It's not about slowing things down. It's about having enough control that you can actually move faster because you aren't terrified of crashing.
I want to address the skeptics for a minute, because I know some of our technical listeners are probably screaming at their speakers right now.
I can hear them.
They're saying, this sounds like a bottleneck, a single point of failure. And frankly, does this add latency?
It's a valid fear. If you implement it poorly, sure, it could be a bottleneck. But the expert analysis in the source suggests that a well-architected control plane actually reduces latency.
How is that even possible? You're adding a step.
Think about the spaghetti alternative.
Yeah.
Right now, service A calls service B, which calls service C. The daisy chain is slow and fragile.
And if one link breaks, the whole thing fails.
Right. A purpose-built control plane uses caching. It's optimized for high-speed decisioning. Checking one central rule set is often much faster than waiting for 3 legacy systems to talk to each other.
So it's actually cleaning up the traffic jam.
It allows you to optimize. Plus, you get resilience. If one of your AI providers goes down, the control plane can instantly reroute to a backup model. You can't do that if the API call is hard-coded into your app.
So we have the problem, we have the solution. The obvious question is, why now? Companies have been running on spaghetti code for 20 years. What's the breaking point?
It's a collision of 3 forces. First, AI adoption is accelerating. We are putting probabilistic decision-making everywhere.
Right.
Second, regulatory pressure is increasing. Governments are demanding to know how AI makes decisions. You can't just say the black box did it.
And third,
operational complexity has just hit a wall.
Huh.
The cost of that exception economy is becoming unsustainable.
It's the straw that broke the camel's back.
Right.
Or maybe the AI that broke the camel's back.
The source material puts it quite bluntly. You don't need more tools. You don't need more dashboards. You don't need more heroics.
I love that line. You don't need more heroics because so much of modern business relies on those heroes. Someone staying up until 2 a.m. to manually fix a broken data sync.
Precisely. You cannot scale heroics. You need a way to govern execution as a living system.
So let's bring it all home. We started with the accidental architecture, this geological layer cake of code nobody understands. We moved to the exception economy, where the edge cases are eating the budget.
And we looked at the control plane as the solution, not ripping everything out, but placing a brain on top of it all. Execute locally, govern globally.
I think the biggest aha moment for me in reading this was the realization that AI didn't actually break enterprise execution.
No, it just turned on the lights.
Yeah.
It revealed that governance was missing all along. We could get away with it when things were simple and deterministic. But in a probabilistic, AI-driven world, the lack of a control plane is an existential risk.
It's like we were driving on a dead straight road, so we never noticed the steering wheel was loose. Now we're on a winding mountain pass.
And the speed limit just went up to 100 miles per hour.
Exactly. So for everyone listening, here is the thought I want to leave you with, straight from the source material. As you look at your own company systems, at your own geological layer cake, the question isn't whether to add a control layer.
The question is, how much longer can you afford not to?
That's it for this deep dive. Thanks for listening, and good luck finding that steering wheel.
Until next time.